Algebra 2 trigonometry, the sum and product of the roots. What are the sum, s, and product, p, of the roots of the equation 3x squared minus 7x plus 12? We have two formulas that we need to really use for the sum and the product for the roots. The first one is it's a pair. The sum of the roots can come from a quadratic equation in standard form as negative b over a, and the product of the roots can come from c over a. Now, what are a, b, and c? They are these three numbers. And so a in this case is 3, b is negative 7, and c is 12. That's just like we did the quadratic formula, a, b, and c. So your sum is simply negative b over a, c over a. And your sum is negative b over a, and your product is c over a, excuse me. So the sum here would be negative b. Now remember, negative b just means the opposite sign of b. So if b is negative 7, that's going to be positive 7 over a, which is 3. And that's right here, these two. And the product, c over a, would be 12 over 3, which we can simplify down to 4. And so the only one you change the sign for at any point is your b term. So 7 over 3 and 4 is choice C. That's all you needed for this question, but the other formula I also want to put down now is that all quadratics can be written in standard form as x squared minus parentheses the sum of the roots x plus parentheses the product of the roots equals 0. And so what that means is if we, say, wanted to go the other way, say we had the sum and product and wanted the equation, well, once we have these, we could plug that in here. And so that would be x squared minus the sum is 7 over 3, so minus 7 over 3x plus the product is plus 4 equals 0. So x squared change the sign of the sum x, and then plus the product equals 0. But how come this equation that I wrote here in green doesn't look like this equation up here? Well, it's because of this 7 over 3. So what happens is if you end up with a fraction in your answer here, what you could do to get rid of this divided by 3 is multiply everything by 3. And so if I multiply everything by 3, I get 3x squared, right? This times 3. And this times 3 will get simplified with this other 3, and you're just left with minus 7x. And this times 3 will give us the plus 12. And that is the equation that we have up here. So two key formulas, the negative b over a, c over a to get the sum and product, and x squared minus sum x plus product equals 0 to get the equation from the sum and product. Write a quadratic equation such that the sum of the roots is 6, the product of the roots is negative 27. That's simple. That's x squared minus the sum of the roots, x, plus the product equals 0. So that's going to be x squared. The sum is 6, so minus 6x. The product is negative 27, so minus 27 equals 0. Done. Simple. Write a quadratic equation such that the sum is 2/3, the product is 4. That's going to be x squared minus the sum, or opposite sign of the sum would be minus 2/3 x, and the product is 4, so positive 4 is plus 4 equals 0. Multiply this 3 out, gives me 3x squared minus 2x plus 12 equals 0. This times 3 is 3x squared. This times 3 cancels the bottom, just left a negative 2, and this times 3 is 12. That's it. Pretty simple. Last question. Which quadratic equation has the roots of 2 minus rad 3 and 2 plus rad 3? Well, for this one, you have two options. You could do the quadratic formula or completing the square and test all these, or we could use this formula we've been working with. If we know the sum and product, we could put it in the equation. This isn't the sum and product. These are the actual roots. Well, it's pretty simple. We'll do the sum and the product. Sum means add the roots together. So that's going to be 2 minus rad 3 plus 2 plus rad 3. And because these are conjugates, the annoying part, the plus minus rad 3, cancels out when you add these together. And it really just becomes 2 plus 2 is 4. The product is multiplying your roots, 2 minus rad 3 and 2 plus rad 3. And again, multiplying them would require FOIL, but they are conjugates, so you could just do the first and the last terms. 2 times 2 is 4. Plus rad 3 and minus rad 3 multiplies to negative 3. 4 minus 3 is 1. So you get a sum of 4, a product of 1. That's going to be x squared minus the sum, so minus 4x, plus the product, plus 1, equals 0. X squared minus 4x plus 1 equals 0. That's it. So to get the equation from the roots, you do the sum of the roots, which means add, and you do the product of the roots, which means multiply, and then you plug it into the x squared minus some x plus the product. And so it's really not too bad. Some people see this and they think they got to do like reverse quadratic formula, something like that. Not that difficult. Just take the sum of the roots, take the product of the roots, and go from there. And that's what sum and product are. Is if we actually factored and solved and got the roots, sum is adding them together, product's multiplying them together. So not too bad for this video. We just see negative b over a, c over a to get sum and product, and then this equation to get the quadratic from the sum and product. And sometimes you're going to be given the sum and product. Sometimes you actually got to calculate the sum and the product and then plug it in. That's the bell. Video's over.